This isn't Hollywood fiction. 3:14 a.m. Persian Gulf time, a massive detonation erupts from the ocean floor, sending shockwaves through one of the world's most advanced naval fleets. The explosive charge vaporizes instantly into a sphere of crushing pressure, collapsing to generate an underwater shockwave racing at 1,500 meters per second, slamming directly into reinforced steel hulls. The USS Jack H. Lucas, America's newest guided missile destroyer, takes the full brunt of the blast. Its keel, the load-bearing backbone of this steel leviathan, bends like brittle plastic under impossible stress. Electrical systems cascade into failure. The piercing shriek of tortured metal mixes with the relentless wail of emergency alarms cutting through the darkness. Iran's naval commanders believe they've crippled the monster, but they've actually triggered the most devastating retaliation network in military history. Operation Praying Mantis 2.0 has officially commenced. The Persian Gulf transforms into a tactical pressure cooker. The Sasson oil rig, a towering offshore structure, operates as Iran's primary command and intelligence hub, coordinating massive drone swarms and coastal artillery batteries. To clear the operational corridor for fleet movement, this digital nerve center must be severed. 3:20 a.m., 50 nautical miles distant, the USS New Jersey, a Virginia-class Block 5 attack submarine, initiates a silent strike protocol. Instead of conventional torpedoes, it deploys a specialized unmanned underwater vehicle, a mechanical predator gliding along the seafloor, systematically locating the fiber optic cables connecting Sasson to mainland Iran. With surgical precision, the UUV severs the digital lifeline, completely isolating the drilling platform. Sasson becomes a digital island, silent, blind, and utterly cut off from Iranian command structure. Nor istin than Surinsen, nor istorn. Blind and utterly cut off from Iranian command structure. Noligen stu. Motherfins noi fixan, noli stui couch hoftan. Lucas begins its counter-offensive. The moment primary power systems collapse, the Starshield satellite constellation in low Earth orbit automatically detects the emergency distress signal. The Starshield network instantly establishes a space-based data link, enabling the Lucas to acquire Tomahawk missile targets even before its Aegis combat system completes full restart procedures. Thanks to this orbital data stream, the Lucas, teetering on the edge of operational failure, maintains target acquisition capabilities without waiting for complete system restoration. 3:30 a.m. marks the critical decision point. The Lucas deliberately avoids stealth mode. The captain orders the AN-SPY-6 radar array to remain active, emitting weak, intermittent signals that appear on enemy sensors like a massive ship gasping for survival. This calculated deception creates a digital siren song, a sophisticated decoy designed to lure the Iranian fleet from their protected anchorage into a killing zone they cannot anticipate. Hone. While the USS Jack H. Lucas stands isolated in hostile waters, it operates within a broader tactical network. 150 nautical miles beyond the horizon, the supercarrier USS Abraham Lincoln maintains combat alert status for 48 continuous hours. If the Lucas serves as the striking fist, then the Lincoln functions as the operational brain, the central processing hub of a lethal network determining precisely where and when devastating blows will fall. 3:43 a.m. The trap springs into action. Iranian command, deceived by the Lucas's radar deception, unleashes a coordinated nightmare attack comprising hundreds of Shahed-class suicide drones and explosive-laden unmanned surface vessels. These low radar cross-section targets saturate the Lucas's detection horizon, creating chaotic phantom signal clouds. Hidden within this electronic storm, Iran launches a Ghadir anti-ship cruise missile, skimming the water surface and exploiting the drone swarm chaos as protective cover, obscuring the Lucas's targeting sensors. 3:48 a.m., the Aegis Baseline 10 operating system, the first naval platform integrating deep learning artificial intelligence, assumes complete battlefield control. Within precisely 0.1 seconds, the AI target discrimination algorithm activates, cross-referencing kinematic behavior patterns, thermal signatures, and radar variations of each contact against a database containing millions of known flight trajectories. The AI instantly filters phantom targets and identifies the genuine threat, the Ghadir missile lurking within the electronic maze. 3:50 a.m., the Lucas's vertical launch system fires in rapid succession, sweeping targets with machine-like precision no human crew could match. SM-2 missiles launch in coordinated salvos, clearing drone swarms like a kinetic broom sweeping debris. Simultaneously, the system designates an SM-6 interceptor to eliminate the Ghadir missile. The SM-6 intercepts the cruise missile 5 miles from the ship, converting it into a massive fireball, blazing against the pitch-black night. The swarm shatters, jamming shields destroyed, but enemy forces continue escalating. While SM-2 missiles clear long-range threats, surviving suicide drones penetrate the defensive firewall, charging directly toward the Lucas's radar mast. This moment marks Helios Laser Systems' first real-world combat test. A 60-kilowatt laser beam sweeps across the horizon, burning out the sensors of the most persistent drones at close range, protecting the ship's electronic brain before they inflict damage. This demonstration merely previews the true destructive potential of directed energy weapons. 4:03 a.m., realizing their swarm attack failed completely, Iran escalates with their ultimate weapon, the Khaybar-Fars hypersonic anti-ship missile system. They execute a salvo launch, firing 2 missiles in rapid succession toward the Lucas at speeds exceeding Mach 3. The first missile serves as a tactical sacrifice, programmed for premature high-altitude detonation, creating a localized electromagnetic pulse designed to disable the Lucas's sensors and generate a digital blind spot in the sky. As the first explosion paints the horizon with eerie blue electromagnetic discharge, the second Khaybar-Fars missile plunges into that blind zone at speeds exceeding 1,000 meters per second. Due to Earth's curvature and EMP interference, the Lucas's onboard systems remain completely blind to the approaching hypersonic predator. But the Lucas doesn't fight alone. The USS Abraham Lincoln activates its extended sensor network. At 30,000 feet altitude, an F-35C Lightning II maintains silent surveillance, supported by an MQ-25 Stingray stealth refueling drone lurking at the combat zone's periphery. The F-35C maintains sufficient fuel reserves to keep its electro-optical targeting system on maximum alert status. 4:08 a.m., the termination network activates, using the multifunction advanced data link, a stealth-oriented, nearly jam-proof communication channel. The F-35C transmits fire control quality target data to the USS Abraham Lincoln. The carrier's combat computers process trajectory calculations and immediately feed direct fire solutions into the USS Lucas's weapon systems via the strike group's cooperative engagement capability network. 4:15 a.m., the Lucas executes a launch on remote engagement. it fires an SM-6 interceptor into the pitch-black void. The Lucas displays absolutely no radar contact on its screens, but the SM-6 receives perfect guidance from the F-35C's remote sensors. Interception occurs 40 miles from the ship beyond the radar horizon. The SM-6 slams into the K-bar FARs in the upper atmosphere, destroying the hypersonic threat before it penetrates the ship's defensive perimeter. This represents the pinnacle of sensor fusion technology, a surface combatant destroying a killer it never actually detected. 4:20 a.m., the battlefield shifts from kinetic firepower to the invisible deadly realm of electronic warfare. Realizing missile strikes failed, Iranian commanders activate a terrifying contingency plan involving autonomous swarms. Hundreds of small drones switch to autonomous mode, severing all radio communication with their control base, flying entirely on pre-programmed artificial intelligence and internal inertial navigation systems. This renders traditional U.S. jamming tactics useless, as no signals exist to interfere with. Simultaneously, Iran's coastal electronic warfare units initiate home-on-jam protocols, attempting to reverse engineer and lock onto U.S. aircraft positions by tracing their electronic emissions. Above the battlefield, an EA-18G Growler from the USS Abraham Lincoln's Air Wing prepares electronic retaliation. 4:25 a.m., the Growler pilot activates a high-risk cyber attack maneuver known as DRFM malware injection, utilizing the next-generation jammer's massive power output. The Growler transmits self-replicating malware directly into the drone swarm's visual processing chips. This malware seizes control of computer vision algorithms, rewriting their digital reality within microseconds. Relined Sisengyen Contrin chip. 4:28 a.m., the swarm's digital reality inverts completely. The drone swarm's artificial brains perceive calm sea surfaces as high-value U.S. warships, while the USS Jack H. Lucas effectively disappears from their sensors, registering only as empty water. 4:32 a.m. produces complete kinetic chaos. Iranian drones, blinded by compromised vision systems, suddenly plunge violently downward, crashing into the Persian Gulf at 200 miles per hour or colliding with each other mid-air, triggering chains of consecutive explosions. The Growler achieves total victory without firing a single kinetic weapon, converting the enemy's most advanced autonomous swarm into their underwater graveyard. 4:40 a.m. initiates the final counterattack phase, designated Alpha Strike. The Iranian surface fleet, realizing electronic jamming and swarm tactics failed, attempts the hide-in-chaos maneuver. They position frigates and missile boats between massive civilian oil tankers, using neutral vessels as human shields to block U.S. attacks. To further complicate radar pictures, they deploy massive chaff clouds, creating dense whiteout conditions on radar screens, blurring distinctions between warships and merchant vessels. 4:45 a.m., the execution order transmits from the USS Abraham Lincoln's Combat Information Center. A squadron of F-35C Lightning II fighters enters the combat zone from the south. Each stealth fighter carries AGM-158C LRAS-M missiles. These aren't traditional missiles, but stealthy, semi-autonomous hunters that don't rely on GPS or active radar, both heavily jammed by Iranian forces. To secure safe passage for the F-35C squadron, the submarine USS New Jersey activates its vertical payload module launch tubes from deep underwater. Instead of targeting the surface fleet, it launches Tomahawk Block 5 missiles against enemy S-300 coastal air defense batteries. This strike forces enemy radar to pivot, creating safe corridors for LRASM missiles to penetrate without land-based interception. 4:48 a.m. After launch, the LRASM squadron begins AI coordination via secure internal data link networks. The missiles operate like wolf packs, sharing sensor data in real time to solve tactical puzzles. They utilize automatic target recognition algorithms to match thermal signatures and optical profiles against internal 3D databases containing every Iranian Navy vessel type. 4:52 a.m., the LRASMs select their targets. Completely ignoring civilian oil tankers, the missiles divide into specific attack roles. The strike becomes a masterpiece of synchronized destruction. Missiles 1 and 2 strike the Iranian flagship's upper deck at shallow angles designed to vaporize radar masts and communication arrays, rendering the ship paralyzed and blind. Fractions of seconds later, Missile 3 executes a steep climb before plunging vertically through thin deck armor to detonate inside the engine compartment. The Iranian flagship tears apart from inside out without a single radar alarm sounding. The stealthy LRASMs slipped past jamming and defensive shields like invisible phantoms. The Iranian fleet's center transforms into flaming wreckage before they realize they're under attack. 5 a.m., the battle screen displays a mosaic of debris and heat signatures. Despite widespread devastation, a high-speed contact emerges from the smoke. An Iranian fast attack craft, having lost radar and coordination capabilities, launches a desperate blind attack at 45 knots, aiming unguided rocket launchers at the USS Jack H. Lucas's starboard side. The Lucas coordinates power distribution systems to prioritize directed energy weapons, bringing its most advanced defensive systems online. A low-profile deck turret swivels with surgical precision. This is Helios, the 60-kilowatt high-energy laser system. The invisible laser beam locks onto the enemy missile launcher. Within 5 seconds of thermal saturation, the steel casing of the missile launcher undergoes molecular structural breakdown, glowing white-hot before solid fuel reaches ignition temperature. 5:05 a.m., the craft incinerates from its own weapons before entering 3-mile range. The strike remains silent, absolute, and devastatingly technical, a precise elimination of the final kinetic threat on the sea. But envision scenarios without conventional gunfire, pure digital execution. Iranian fleet cooling control systems operate as closed-loop networks. Once compromised by malware, heat from their engines and ammunition creates internal furnaces. Without missiles, cyber warriors seize control of cooling systems amid the Gulf's 50-degree temperatures. When systems fail, entire ammunition compartments self-detonate due to internal overheating. No radar targets, no external smoke or fire. Entire fleets self-destruct from single lines of code. In 2026, the most destructive weapons aren't explosives, but enter commands executed from halfway around the globe. The future of warfare isn't about bigger bombs or faster missiles. It's about invisible networks that can turn an enemy's own systems into instruments of their destruction.